Before continuing any further, you might want to save your project. So File, Save. I'm going to save it with a name like this, just a preliminary project. Projects are by default saved with a .zee extension. And now your project file name will appear in the menu bar of your HistoloZee window. I'm going to go to the Finder and inspect that project. So you'll notice that this project is actually nothing more than an XML file containing a description of everything that we've loaded into our alignment project. It begins with this HistoloZee project tab, which encloses everything. And slides are contained within the slide stack tab. The start of the stack is indicated with this comment, and the first slide goes from there to there. All file names are relative to where you have placed your project file, and you'll notice that each slide has an image, in this case the aperio.svs image, which is about 1 GB in size, as well as a metadata file with the same name but XML file extension, which holds slice-specific parameters that I'll show you in just a minute. We also are given in a comment the K index. So again, K is the coordinate system that goes into and out of the view plane. K equals 0 being the first slice. We have view properties and the transformation parameters that we've applied. Transformations are applied in physical coordinates of millimeters. So these translations are actually in millimeters with respect to the horizontal and vertical directions of our view. I being the horizontal view direction, J being the vertical view direction, and K being the direction into and out of our screen. For convenience, we have also supplied within a comment the two-dimensional affine transformation of each slide. Rotations are specified in angles. So after our last slide and the end of our slide stack, we have the orientation matrix. This matrix is the mapping from IJK slide coordinates or view coordinates into XYZ world coordinates. And within comments, we have just shown that this matrix corresponds to an RSA orientation, or right superior anterior orientation, which is the default orientation for coronal sections. We also have a segmentations label tag, which I will discuss a little bit later. These are the default segmentation label names and colors. Now I'm going to go into the slice directory, which is here in KB, and this is our first slide, F01. You'll notice that several other files are created in addition to the slide itself. We have the XML file for the slide, so the XML file of each slide gives the pixel size of the slide in millimeter units. So this is about half a micron in both the horizontal and vertical directions. The slice spacing in millimeter physical units. The slice thickness, as well as some color correction parameters which are applied independently to the red, green, and blue channels of your slides. You are able to scale and shift the red, green, blue color components independently for each slide. Additionally, each slide has an Svg segmentation attached to it. In this case, we've actually already gone ahead and segmented that hippocampus into its subfields, and these are just very standard Svg files. I'll open up one here in the text editor utility, and you can see that our slide segmentations are stored in XML format as well. All right, back to our project.